There we go. I'm Dave, Senior DevOps Advocate from GitHub. Thrilled to welcome you here this evening. First of all, just a couple of things we always go over. And it helps to turn the clicker on. There we go. Help us keep things clean. We'd love to welcome you here, but when you're done with your pizza and things tonight, please do dispose of it properly. If you need something, ask one of our community managers or myself. We can make sure there's more cups for water if we need and things like that. If you see any questionable behavior, also please let us know. If you see something, say something kind of thing. We're thrilled to welcome you here, but we want to all work together and make sure we can continue to do these things. So I have posted this PDF on Slack already, so you can get all of these links and everything that I'm going to show if you're in Slack. But here I always have this list of resources for GitHub Copilot. GitHub Copilot continues to evolve, continues to expand, and some of the recent things to talk about here is keeping up with our blog post and change logs. And we even created a section on the blogs now for just AI and ML. So be sure to check that out. The big thing for us coming up later this month, now that we're in October, is GitHub Universe, the 29th and 30th. It will be in San Francisco, but I believe most all of the sessions are also going to be streamed live virtually and will be posted online, on YouTube and at our githubuniverse.com afterwards. So we'll have lots of announcements. We'll have lots of enterprise customers that work with, even some of our partners like JFrog will be talking about some of their innovations through our integrations with things like Copilot extensions and such. But yes, real quickly, some of the announcements. We are starting to work with other models now with GitHub Copilot as well, including the O1 model. So check out that blog post to learn more about that. The Copilot extensions are now in public beta, and a couple of them that were announced with the public beta. Atlassian has Copilot extensions that work with information coming from Jira and Confluence in your own instances of Jira and Confluence. And JFrog works with Artifactory and X-Ray and things like that. So these best of breed tools are integrating with GitHub through Copilot extensions, in addition to the GitHub apps and things. Also, chat is available now in github.com for Copilot business users. You don't have to have a Copilot enterprise license to be able to use chat on github.com. So be sure to check that out. We're also we're applying AI ubiquitously throughout the GitHub platform. A big announcement we recently had is as we find vulnerabilities with CodeQL, our code scanning tools for finding security vulnerabilities in the code that you're writing, we now have Copilot Autofix, which will suggest fixes for those vulnerabilities. So as a developer, you can say, oh, okay, I see how that code needs to change. Oh, I'll just apply this change. You don't have to go out and become a security expert. You can leverage the AI and work with those suggestions. Larger context windows and things. So be sure to check that out. Oh, and when you're working with Copilot Chat on github.com, it will now also take into account issues and pull requests and a lot of other repositories, other topics. You can find information about commit history and things like that. Lots of announcements. I'm trying to go through quickly here. Custom models, being able to do additional training on your own code so that as you're generating code, it will take into account the patterns that you use, the style that you use. If you have your own internal APIs that you use across different packages or applications, just within your enterprise. Now you can train the models so that as new code is generated, it'll take that into account. Oh, I have that one repeated. So that's all for me. Please enjoy tonight's event.
All right, thanks, David, for the hosting us and the introduction for the GitHub service. Great. So let's jump right in. So, we have our first speaker, Wang from Tecton, and he's going to speak talking about how to enhancing the context provisioning for large language models beyond RAG and prompts. So without further ado, let's welcome Han.
Hello, everyone. I'm so excited to see so many people in Seattle. That is not common. And I believe my boss will be very happy to see so many people coming to our talk. Thank you so much. So let me share. Okay. Okay. Did you guys have a good dinner today? Cool. Sounds good. Yeah. Thank you so much, Bill, for feeding us with pizza. And today, excuse me, what is coming? Oh, more pizzas. Oh, I see. More pizzas. Nice. I see. Yeah. Yeah. So, Bill enriched us with pizza. And now we are talking about how we can enrich the large language model with context. And we're going to discuss, like, are we doing the right things and what can be done? Okay, and a brief introduction of myself. I'm currently the lead engineer of GenAI in Tecton. Before joining Tecton 4 months ago, I was the head of machine learning platform team of Lyft. Okay, so before I start, I want to do a very quick survey. Like, how many people here are working on GenAI projects? I mean, in production or near production. Nice, nice, cool. And how many people think context is important for GenAI? Nice, almost everyone. Oh, even more, interesting, interesting. And then how many people are using RAG in your AI projects? I think maybe 80% of the people who are working on AI projects are using RAG. Okay, so today we're talking about RAG and other things. So I think I'm going to use a hypothetical scenario through this talk. Assuming that Julia's money transfer account was suspended, and assuming that we have a money transfer company and we're building an app, and we build a chatbot to support our unhappy customers, and Julia is now very unhappy. And if he has a question like why my account was suspended, the first thing, I mean, the most naive way to solve this problem, because we know we have large language models now, the most naive way is just directly put the input question, I mean, just send the input question to the large language model. And then to get a generation, right? So how does it work? This is Julia, and this is our app with a chatbot. My account was suspended. And how can this chatbot respond with just this very naive implementation? So luckily, it doesn't hallucinate, but it says, unfortunately, I don't have the capability to assist you because there is no context at all. So very, very naturally, you will think about, can RAG help here, right? Because RAG is such a hot topic. Let's take a look. If we want to incorporate a RAG, For example, we have a list of FAQs about money transfer. And what we want to do is to probably ingest that FAQ into vector database. And then in real time, when there is a question coming in, we can send that question, we can embed, compute the embedding of that question, and then to do a similarity search in the vector database. And then we can just push both the relevant chunks of answers as well as the original question to the large language model. So we expect this to give us a better result, right? So if you ask, so here, assuming that we have a FAQ list and we have already ingested that into the vector database. And if Julia asked this question again, my account was suspended. And luckily, if we compute the embedding of this sentence, my account was suspended, and then we do a search. And we find some relevant chunks of the answers. And with those contexts, our very smart large language model is able to say, oh, it may be due to suspected fraudulent activities or age-related restrictions. It's much better. At least I think it answers something that is relevant to our company, right? So it's a lot better. But does it always work? So let's take a look at another scenario. Now, Julia is in bad mood. And she could not even, typing a complete sentence. He said, why did you suspend? Like, what the hell is this? Like, but actually, to human beings, the intent is pretty clear, right? But unfortunately, if sometimes the phrase is a little bit different, and then you cannot get relevant chunks from your vector database, depending on how you set up your vector database. And in this case, it cannot find any relevant chunks. And so it says, I'm not able to assist you. I cannot find any relevant information. Yeah, so actually this is pretty common if you just want to use RAG in the very naive way. A common technique to fix this problem is actually, instead of directly using your input question, original question, which has a lot of irrelevant content and maybe also typos, you can call the large language model to rewrite your question into one or multiple query variations that is much more focused on your intent. And then just use those rewritten queries to search in the vector database, and then to consolidate the candidates to get the generation, to get a large language model to generate the final answer. So this is a very common technique, and sometimes it works well, okay? So, but now let's see, with this kind of implementation, can we handle the next question well? So, we expect the customer to ask something that's relevant to our FAQ list. But you can never know what the next questions our customer is going to ask. Now she's saying hello, which has nothing to do with the FAQ, right? It's just a greeting. So what will this workflow do is it will just use whatever input Julia has, compute the query variations, and then to query the vector database and to get candidates. And so no matter what kind of things you type in, you will get a bunch of candidates, and then use those as context to generate the answer. But luckily, our large language model is smart enough, and it knows, oh, I need to discard all the context because this is just a greeting, right? So, hello, how can I assist you? But you can think this is pretty inefficient. You add one more large language model call, you add a couple of unnecessary requests to your vector database, plus in the end, you have much longer context to process, increasing your cost and the latency for the whole generation of workflow, right? So this is not necessary. So how can we solve this problem? There is another common technique where you can have an intent classifier. If you have an intent classifier, And only if the intent is relevant to the money transfer, you do the rewrite. And then you use vector search. Otherwise, like a hello, it will just go directly into the large language model. So with this approach, you can save a lot of unnecessary operations. Looks good, right? So now let's see if it can handle the next question well. So the next question is, my account was suspended. Can I create a new account? What happened here? So yeah, so actually this query has two intents now. One is suspension, another is creation, multiple intent. As I said, you never know what the next question the customer is going to ask, right? How can we solve this problem? So there is a common technique, which is you can have a multiple intent classifier, given multiple tags, and based on those intents, and you can query, you can do multiple rewriting and vector search, and then consolidate the results. But the thing here is, after just a few examples, you see how complex this workflow is. And not to say who is going to write this workflow. I mean, how do you construct this workflow programmatically? Actually, I can tell you there are a lot of solutions, like a prompt management, prompt flow. Like if you use Bedrock, Bedrock has the prompt flow. It's exactly for this kind of thing. But think about that. Is this realistic? I mean, there are a whole bunch of other scenarios that you don't even think about. This approach just doesn't scale. Even there are nice UI tools for you to create this kind of flow, right? So what's the problem here? The problem is you always have, if you want to ensure the RAG work reliably and robustly, you always have to put significant amount of manual effort, right? But how can we solve this problem? So notice that you always have to handcraft your workflow in order to handle a new scenario, right? So that handcrafted workflow defines how this workflow should do, like how to do, right? But instead, actually, you should think about a totally different way, which is agentic workflow. What's the difference between handcrafted workflow and agentic workflow is handcrafted workflow solves how to do. You define how to do. You are a micromanager. And agentic workflow, you just define what to do. You delegate and you provide the agent with a collection of optional tools and for the agent to figure out how to do. And I just want to mention that this is not a new idea. Actually, this agentic way to do generation is actually natively supported by all major large language models as of today. So whatever large language model you use, I mean, main large language model you use, you can do this natively. So now let's take a look how agentic workflow works. If you have an input question, the input question will go into an agent. This agent has a brain, which is the large language model. And this agent also is provided with a collection of tools. And one of the tools, this yellow one, is to retrieve relevant information using query from the FAQ list. Probably behind that tool, it is a RAG. It's possible, but maybe you can do something else. Okay, so given a collection of tools, given the brain, the large language model is able to figure out the workflow by itself and execute. So this is totally different from handcrafted workflow because now this becomes a totally dynamic process and you rely on the capability of large language models to figure out how to do. And getting back to our original example, what we could do, I mean, it's not exactly like this, but you can imagine it's similar. If in the system prompt, I tell the large language model that, oh, you have a tool to search the FAQ, right? And now if you ask hello, then large language model knows, oh, this is just a greeting. I don't need to use this FAQ tool. It has nothing to do with this tool. So I would just directly return, hello, how can I assist you? Without invoking this search tool. But if you ask something, follow-up question, my account was suspended. Oh, this is related with the FAQ. Then it will just invoke that tool and give you a relevant answer. So this agentic workflow, or I call this agentic RAG. Maybe I saw someone call this agentic RAG. Actually, in practice, it works much better than the static way that I just showed. So after we talk about this agentic RAG, the next question is, does this solve all the problem, or is the RAG sufficient to solve the context problem? Let's take another look at another example. But before that, I just want to make an analogy. Like, is a RAG sufficient? It's just like, is pizza sufficient for today's dinner, right? So how about some snacks, right? So it's the same. Like, is RAG sufficient? Let's take a look at an example. Let's get back to the original scenario where you ask, my account was suspended, and then it answers something. But then Julia is not happy. She asks, based on my information, why? So Julia is saying that you have my personal information. Why cannot give me a personalized answer, right? But just using the general RAG, you cannot do that. How can we solve this problem? I have this user ID. I also have the user's profile, like age, name, and other information. Maybe a quick solution, quick dirty solution is just to put all the user ID plus user profile also into the vector database. And then when you say, based on my information, oh, I will just search the user ID in the vector database and to get maybe n top similar result. And then I just find the one that the key is matching user ID. But as you know, this is totally unnecessary, right? This is the wrong way. This is the most wasteful way to use vector database, right? So we shouldn't do this. The problem is vector search is similarity search. But for a lot of structured context, you should do exact match. Okay, exact match and similar search are totally different things. You must make clear in your mind. So how can we solve this? The first thing I want to say is mentally, you have to be clear that structured context is actually equivalent important compared to unstructured context. Okay, and the second thing is, if you want to serve structured context, you should prefer exact match. In another word, I don't want to make it so fancy. It's not like exact match or similarity search. It's actually, I'm saying serving the structured context in the traditional way. Nothing fancy, nothing related with large language models. But do you already have a traditional way, like, for example, KV store, Redis, to serve your structured context? Actually, that is very, very important for large language models performance. Okay, so now let's assume that you put the user information into a KV store. And now we can construct a more meaningful system prompt. Where in the system prompt, we can in real time populate based on user ID, I can get, oh, your name is Julia and your age is 16. Now, if I ask this question again, large language model will also query the FAQ to get the general policy and then incorporate with your personal information like your age and name. And the answer is our age requirement is 18. Since you are 16, that may be why your account was suspended. It is way more personalized. And actually that can save a lot of like a back and forth conversation. So this is personalization, which is pretty important if you want to build a customer support chatbot. Yes?
Why?
the account was created before.
Can you repeat your question?
Oh, I'm sorry. Okay. So when the requirement is 18 years old, why the account was created before?
Because of some bugs, some softwares, maybe software engineers.
That means,
they maybe
the regularities,
some
we
sort
not
of like
follow
a
them.
unit test or something.
Okay.
Thank you. Yeah. So that's why we need competent software engineers. At least you should add some unit tests in order to make sure there is no such silly mistakes. Okay, so now, similarly, what you can do is you can put more personal context into the system prompt so that it's more capable. For example, now if Julia is 28, and I can also put like money transfer in the last 1 year, money transfer in the 7 days. This kind of information, if you and if incorporating with the general policy, and also will be the activity seems abnormal. Now the age has no issue, but your activity is not normal to large language model. Again, it's a very nice explanation of the situation, right? So similarly, you can put even more context. For example, where do you attempt to do the money transfer? And also the amount transfer in the last 1 year, 7 days, things like that. You can add like 100 items to the system prompt. But the question is this the right way to do this? Is this really the best way? Actually, the problem here is you cannot put everything you know into the system prompt. Why? Because it takes time, right? If you make like a 10 calls in order to get those relevant context into a prompt, maybe in the conversation, we will just use one, right? So it's not efficient and it's not effective because the more irrelevant context, the more distracting to the large language models, right? So this is a problem. What is the solution? So actually, we need to make clear that there are 2 ways to provide GenAI with context. The first way is conversation independent, meaning that you don't really know what the conversation is going to talk about before the conversation. I need to put some very basic stuff into the system prompts. System prompts is the right solution for some very basic common information. But if it is conversation dependent, you never know where the conversation goes to, right? So if it is conversation dependent, then actually you should use tools. Tools is one of the most important concepts in the agentic workflow. So, and again, these kind of agentic workflow is well supported by all major large language model vendors. So again, let's take a look at the original example. And now we just want to add another tool to it, the purple one. The purple one represents a function that can retrieve certain information from a KV store. Now you have 5 different tools, and just let large language model to figure out what tools to use and how to use. Let's take a look at the real example. Now the system prompt becomes, the current user is Julia, age 28. But meanwhile, instead of providing all those kind of context values, instead I tell the system what kind of retrieval tools I have, get number of transfers, get transfer preference, get transfer amounts. I just tell him what I have. If you need, just call that function, okay? If I ask again, now large language model is able to figure out, oh, for your question, probably the 2.1, 2.3 are relevant. So it will just call these 2 tools, get the context, and then to incorporate with the context you retrieved from FAQ and the answer, the fully dynamic way. So here, let's take a look at the bigger picture. We have had a lot of different scenarios. We went through a lot of different things, right? What is the bigger picture? The context for Gen AI, I would draw a 2x2 grid. And we can categorize the context data to unstructured data and structured data. And on the other way, the ways to serve, I can categorize them to static and dynamic. So be specific to our example. Unstructured data, FAQ, the answer data are unstructured data. And here we just use the dynamic way, the agentic way to serve the FAQ data, right? For structured data, something we can serve statically, the user profile, location information. Those are pretty common information that could be, and actually time. This kind of very common information you can use anywhere in any step of the conversation. And for the dynamic thing like transfer history, very specific context information, just to treat them dynamically as tools, and then just to retrieve them only when necessary. So I think this is the bigger picture of the context and how you should design the retrieval steps, okay? So, but even with that bigger picture, there are still challenges. So look at this chart, right? We talk about raw data to vector database and to large language model. We talk about raw data to KV store, which is structured data, and to large language models. So what you have been reading in the last couple of months or 1 year is all about vector DB serving vector DB data, right? So I think this vector DB to large language model is a well-solved problem. But on the other hand, the ingestion and the transformation and ingestion from raw data to KV store, from raw data to vector database, or the KV store serving to large language model, I don't see a systematic solution of this. Probably different companies can figure out their own way, but there is really not well-defined solution for all this. To summarize them in text, continuous ETL from raw data to KV stores or vector stores, and stable and scalable ELT for serving the structured data. Combining, how can you combine both structured data and unstructured data as context for a large language model? And the last but not the least, how can you host the end-to-end agentic workflow? I don't see a good solution for this. So that's why I want to sell something here. Why Tecton, right? So why? Because productionizing AI is a massive data problem. And who is Tecton? Tecton was funded from some members from Uber's Michelangelo AI platform. I'm Lyft, we were enemies, and now, we're working in the same company. The mission is to power every customer experience and a business decision. And it was founded in 2018, and it has a lot of big customers like Progressive, State Farm, Coinbase, Sony Square. And also we raised a lot of money. Yeah, true. And the Tecton is a very modular platform. It has different modules. For example, the embeddings, similarity search, or exact match. All those are modules. You can adopt a Tecton incrementally instead of a bundled product. So let's recall what we talk about the context for Gen AI, right? The 2x2 grid. Actually, Tecton has the exact same 2x2 grid. It's just rename something. I mean, it's just based on the Tecton term. The structured data becomes features. The unstructured data become knowledge. The static way become enriching prompts. And the dynamic way becomes as tools for agents. So all other things are the same. So we just define those concepts with different names, but we follow this kind of bigger picture quite well. So now let's take a look at some coding examples. How can we realize the example that we have gone through in the previous slides? So recently, we just released the Tecton GenAI package, which is pip installable. You can just find and pip install it. And in the end, I will also share the tutorial link. So first of all, we need to define user profile. Notice that we have to iterate this problem locally. And in the end, we deploy it to the cluster, right? So now we just define a user profile feature. Remember, we call structured data features. So here we just define the feature of user profile, which I think is quite readable. The data is just a native type, a list of dicts. And then just with 3 parameters, you can define a feature view of Tecton, a Tecton feature view. Okay, with this user profile, now I want to define a prompt that is enriched by this feature view. You probably have 2 records. You can even have 2 million records, 20 million records. It's okay. I mean, it doesn't matter. In the function, what you only need to care is if I get 1 record, which is called user profile, if I get 1 record from somewhere by something, actually by Tecton, and you can just construct, you can just focus on how to construct the meaningful context from that single dictionary. So this is the system prompt. And the next thing is transfer history. Remember, transfer history is also the structured data. So we use the similar way to define. The only difference is here we add a description, money transfer history. Why we want to add a description? Because this feature view, this feature will be used as a tool for the large language model. So you need to explain to large language model what this feature view is about. So it knows when and how to invoke and to retrieve information from this feature view. Okay, so this is the next feature, structured data. Now let's deal with the unstructured data, FAQ. So we have, remember, we have the concept of knowledge. When we define a knowledge, actually we define 2 things. The first thing is ingestion. The second thing is serving, right? Because we need to, first of all, we have the raw data source, FAQ source, right? Assuming that this FAQ source in real production, it will update over time. Every day you can add some more question answer pairs, right? You need a continuous pipeline to ingest that delta change into your vector store. And the second vector DB config is actually for local testing, we have a make local vector DB config. You can change that to any existing vendor databases, for example, Pinecone, VV8, whatever. You can change that. You can bring your own vector database and just to use the config. And then in the end, we just define source as knowledge. Where we define the source, we tell the system which column to vectorize, to index, and then we define name and description because, again, because we want to use this knowledge as a tool, so we need a description so our large language model understands when to use it. Okay, so now this is the most beautiful part is now we're playing Lego. We have built all the bricks. Now we just put everything together, assemble them together. So as you can see, the agent service is the core class for the Tecton's GenAI offering, where you can collect everything together. For prompts, you can give a list of prompts that you defined. Tools, you can either define a real tool. I mean, there is also a decorator called a tool. You can define a tool, or you can directly use a pre-existed feature view as a tool. And then in knowledge, you can just give a couple of knowledges. So yes, actually this agent is able to use multiple knowledge bases. Like if you have quite different knowledge bases, just feel free to add multiple, and you should be able to distinguish them and understand what and when to use them. Okay, so after you define this agent service, you have 2 choices. One is you can directly deploy this to a Tecton cluster so that you can just use remote call, use like a remote client. The client to call the remote service in order to run the whole thing. But I think the developer experience is very, very important. So here I'm just I just want to show you how to test this locally without using the Tecton cluster. Everything is local on your notebook. It's totally fine. So what you need to do is define agent client. And if it is already deployed service, you can say from remote. But here, because we want to do local development, you can just say from local, that service. And then for this agent, you can define the default large language model. As you can see that we have very seamless integration with LangChain. Actually, we also have seamless integration with Llama Index. So here, the large language model object can be either the LangChain large language model object or Llama Index object. Both will work. Under the hood, they will create different agents. Like if you provide the LangChain object, it will give you a LangChain agent. If you provide Llama Index, it will give you a Llama Index agent. And also here, I want to specify the system prompt, which is the sys prompt that's in the prompts. Okay, so now we have everything. We can test locally. Now let's do the test. So the first test, I want to invoke this agent with my question. And here you can see that not only the question, but also the context. So imagine that if you have a phone, if you have an app, right? What is this context? This context is actually the mobile phone context or login context, things like that. So it has, for example, the user ID or some other, like your zip code, your latitude, longitude, all those kind of context information you can put here. And here we just put user ID 1. Let's take a look at the data, actually. So as you can see, for user 1, the problem is age, right? For user 2, actually, the problem is it has 1 year, it has 20 transfers, and in 7 days, it has 19. So that is obviously a problem. Let's see if it can give you the personalized results. So if you provide user ID 1, then it says, oh, note that minimum requirement is 20 years old. Since you are 16, that could be the reason, right? It's highly personalized. And second, the only thing changed from the first 2 seconds is you change the context from user ID 1 to user ID 2. And now the answer is, we notice that you have 19 transfers in the last 7 days. That's abnormal transfer activities. It's hyper-personalized. So that's, I think that's the end of this demo. And in the end, this QR code, if you scan this QR code, you can find the link of the full tutorial. Actually, you can run everything on Colab. I think things should just work. Thank you. So if you have any questions, let me know. Otherwise, I hope you enjoy it. Yeah. Thank you. Thank you.
We do have a question over here.
I guess the natural next question to why was my account suspended is, could I please get my account unsuspended? So do you have any tools to help with that one?
Yes, actually, if you have that suspend the current status of your account as a feature value, and you can put that into your either system prompt or treat that as a tool. So actually, as long as your description of that data source is expressive enough, meaningful enough, large language model is able to use that. But of course, in the whole process, you need a little bit prompt tuning in order to make sure it will invoke that retrieval.
The AI is pretty awesome here, but if I was a user, I would still be unsatisfied because when my account was suspended, I'm sure the system knows exactly why. So why does the AI have to guess it? In this case, can't the AI actually, query the database, figure out what the question is about, query the database, give me a precise answer?
So what's the definition of precise?
Well, if the account was suspended because of age, then I'm sure it's saved in the database somewhere, some kind of code to say why this was suspended. So We just need to fetch that and then put it in words and say, not may have been suspended, but say it was suspended because of this reason.
I see. I see. So I think, so this is my opinion. I think the large language model is not there yet. I mean, you cannot expect it to have 100% precision. So when you say precise, I think you should give some room. And also, I think the way you suggested is actually the same as what's presented here. The only difference is that data retrieved in real time, or is that information pre-computed, right? So the best practice is try to do pre-compute as much as you can, because you really want to reduce the real-time compute load, right? So like if you for example, loading something from the database, actually it's the same like telling Tecton to push that database information to online cache. It's the same, actually. It's the same, yeah. But sometimes you really have to do online compute because you cannot compute everything as feature. I agree. I agree. But I mean, for good practice, try to do pre-compute as much as you can.
Hi. So the sharing the personal user information in system prompts, like what are the compliance boundaries, like AI agents getting access to my personal transfers, user informations? How do you handle those when building such an agent?
So you are asking about the compliance or the data privacy of this kind of like user information?
Yes.
Yes, yes, I think that's a very good question. So the thing that I didn't show here, I really don't have time to talk about it, but I think that the data isolation is very, very important. So for here, like with the tool, right? So I guess your assumption is that for that tool, the input will be user ID. Probably I have a way to hack it in order to get the profile of other user IDs, right? So here we put a lot of effort to avoid that. But on the other hand, there are some scenarios we want to enable that. For example, I want to get the weather. What's the weather now? Right? So that would just use my default zip code of my phone. But if I ask, what is the weather in San Francisco now? Right? I also have that data. I should be able to query, right? So that isolate or not, it is actually a very important feature for our offering. Thank you.
All right, I think we are behind the schedules. Let's move on, and we are not taking more questions. But he's going to hang here after all of the tech talks, and you can ask more questions. We're going to move on to the next speakers. Thanks so much.
Thank you.
Yeah. Great. So our next speaker is Katie. She's going to talk about multimodal AI and vision inference with Gemini. She comes from Google.
Hello, testing. Can you hear me? It works? Cool. Okay. Let me get logged in really quick. How's everyone doing tonight? Good? I feel cool up here with a microphone. They don't let me do this very often, so. This meeting is being recorded. Okay. Yes. Okay. Welcome, everyone. I am Katie Nguyen, let's fix this. I believe I am. Oh, hello. Okay, perfect. There we go. So welcome. I'm from Google Cloud, and I will be sharing a session today from our workshop that we have called the Era of Gemini. So really quickly, who's heard of Gemini? Wow, a lot of hands. And who's heard of Vertex AI? Wow, a lot of hands. I normally don't get that many, so this is exciting. So in this era of Gemini workshop, we basically have a lot of different notebooks that you can go through. We host them in different cities. So we start from really introductory concepts all the way up to really technical production use cases. So today we're going to be focusing on multimodal AI and what that means with Gemini, and with a special focus on vision inferencing. So a little bit more about me. My name is Nguyen. I'm a developer relations engineer for Google Cloud AI, specifically Vertex AI, focused on generative media. So before we kind of dive into the world of multimodal AI and what that means, I think it's worth kind of backtracking a little bit and seeing how we got here. So if we look at the evolution of AI capabilities and tools as a whole, we start with predictive AI. So predictive AI is this field that uses machine learning and statistical models to predict future events and behavior based on historical data and patterns. So this is all of your problems from classification to forecasting, sentiment analysis, and object detection. And those are all laid out right there for you. So then we jump into generative AI, which I'm sure is a term everyone hears about 50 times a day nowadays. But generative AI is the idea of identifying patterns and structures and finding the meaning that they represent, so that they're able to understand and also generate content based on, these similar characteristics that we learned. And so we take it a step further and we get to multimodal generative AI is what we'll be talking about today. And that's the idea of working with various inputs of all different modalities, including audio, video, text, and kind of reasoning across those as a whole to be able to understand the complete situation and be able to handle more complex tasks. So what do we say when we're talking about the era of Gemini? We're really talking about this era of multimodal generative AI and all of the new use cases that we're now able to accurately reason across based on the various inputs that we're able to take in. So I do have to give my little spiel about Gemini. So Gemini was built from the ground up to be multimodal, which is what we'll dive into later, meaning that it can generalize seamlessly, again, understand across all different modalities, including not only language, as we've seen in the previous talks, but also images, audio, video, and code. Gemini is also very highly optimized. So it gives you the opportunity to choose your different models while also being able to preserve choice. So whether you need a really long context window, Gemini 1.5 Pro now has a 2 million token context window, or Gemini 1.5 Flash, which is at a 1 million context, that's a lot of words, context token window, but gives you a lot of opportunity to really scale and work within your high latency use cases. And then finally, Gemini is built from the ground up to be very safe. It's the safest model that Google has ever put out. And it's a result of a lot of aggressive red teaming with a diverse group of external experts and partners. Okay, so why does multimodal matter? I know we're talking a lot about what it can do, but why is this, such a pivotal moment in AI? So if you think about how children kind of learn as they go through life and their reasoning, they are not told like step by step, this is how you read, this is how you talk. They take in everything as it comes to them. And this world of agents, which we heard about in the previous talk, is the same way. So as we move to this kind of agentic models, we're going to need them to better understand their environment, to reason across all of this as a whole. And how do they reason more effectively? They have more modalities that they can parse between. So not only text input from users, but also video feeds from cameras, code that, the models are trained on, stuff like that. So if you take anything from this, is that multimodality is incredibly important. It more closely mimics the idea of the human brain and helps the models deliver better reasoning and generation across these use cases. So I love computer vision and inferencing, so that's what we're going to kind of focus on a little bit today. I think we've seen a lot of these models in practice, but I think one of the big questions with this new era of AI is also, what does this matter? What's kind of the practical business scenario of it? And a few ones that we've thought about for the case of vision inferencing is e-commerce, which is really great. You know, you could have users shopping online, you could have them upload their own photos, you could have them get really personalized recommendations based on their own images and data when they're shopping and want opinions. We also have kind of the industry or factory use case where you have all of this access to cameras and data that you're able to parse, even in real time, to kind of make sure you're complying with safety standards. And then there's marketing. You know, you can look at LLMs and Gemini in particular as a creative collaborator or agent of sorts. You can work with them to bounce ideas off of. You know, I've definitely done that, like working on a presentation, like, oh, you know, what else could I put in, or how else could I make this more intriguing? So working with them as a collaborator is also helpful too if you don't even use the content that they put out word for word. Or in the media and entertainment space, I think there's a lot of different ways you could go with this in terms of media generation, but also in terms of content moderation, using these models to moderate the content that is generated. So I've talked a lot about Gemini, and now we can kind of dive into it and look at some code samples. So this is our generative AI repo that we have and maintain. Our team of developer relations engineers on Google Cloud works pretty hard to put out a lot of notebooks for all different use cases. So I think in this repo alone, we have almost 200 notebooks of different cases. So everything under the sun you see there, obviously a lot in Gemini, a lot in generative media, a lot of search and conversation, RAG, grounding, everything of that sort. So it's your one-stop shop for getting started with generative AI on Google Cloud. So we also have a lot of sample applications and notebooks you can kind of walk through and find out what you're particularly interested in. So if you go to the short link there, that'll take you to the repo homepage, or we're going to jump to a collab and kind of walk through some examples from a notebook that I have as well, which is the second short link. So I will switch screens here. Okay. So what I'm showing right here is the Vertex AI, most people know about that, console page. And so one of the options that we have in here is Colab Enterprise. So that's what I'm running this notebook in, basically like real Colab, but it does a lot of the authentication and boilerplate stuff for you. So it's super helpful. So for the sake of time, I've already run these examples. I didn't want to make you watch little wheels spin, but we can kind of walk through some of them together. So this is our workshop that we use for the era of Gemini for Gemini 1.5, looking at different multimodal use cases. So we'll be talking about Gemini 1.5 Pro and Gemini 1.5 Flash, which have come out with some new features at our Gemini at Work event last week. So as I mentioned before, Gemini 1.5 Pro is our language model from the Gemini family, 2 million token context window. And Gemini 1.5 Flash is your option if you want to optimize for high frequency tasks to prioritize the model's response time. So part of getting started, you would pip install all of these things here. You would have to authenticate if you were in Colab, but since we're in Colab Enterprise, it's going to pull all of our cloud data in for us, run your project ID, import your libraries. We will grab our models here, define some helper functions just for visualization. And then in the individual modalities, I know we've seen this a million times, so I won't run over these use cases, but if you want to, you're more than welcome to check them out on the repo yourself. So we have textual understanding, we have document summarization, which it's really great. I think with this 2 million, I'm having trouble with this today, 2 million token, there we go, window. I think that equates to about 100 pages of a PDF file. So it is really powerful to be able to input that in all in one chunk. So you can reason across that. We can reason across multiple images that we provide to the model to get specific recommendations, as I was mentioning. We can go ahead and generate video descriptions. Summarization is a huge use case. We can also reason across a code base, which is really helpful in this context window. So we're able to take in a whole repo if we give the GitHub URL. From there, we have different functions to help clone and index it. And then we're able to prompt it. So we're able to create things like an entire getting started guide, or ask it to run through preliminarily and find bugs in the code, or summarize the entire code base, which could be really helpful for onboarding new developers into your project, or even if you're creating an open source project for people to get started faster. It's great at audio understanding and summarization. 1.5 Flash is particularly great at this task. And now we get into the fun part of combining all these modalities. So we have audio and video understanding, and from here, we'll kind of break it down into all modalities. So we're gonna look at some cases with image, video, audio, and text all at once. So we're gonna use Gemini 1.5 Pro for all of these examples. And what we're gonna do here is provide a video file, which we're hosting in Google Cloud Storage, of a behind the scenes ad movie that somebody made with the new Pixel phone. So I won't play it all, but you can trust me, it's there. And we're also going to supply an image from the video that is somewhere located at some point within the video. And so we can prompt Gemini in this way. We can, provide a very unstructured prompt to it, basically asking it to look through each frame and find exactly the timestamp of when this image appears in this video, and then kind of give a summary of the context that's also happening. And so I already ran this cell, and we can see that, it's very polite. Of course, here's your requested information. It happens at 0:48, which, just to fact check it, there we go. So it hit that one right on the spot. And we're also able to see that it's kind of giving the behind the scenes of the video, how it's the story of making a documentary from the perspective of somebody who's blind. So now we get into those kind of 4 use cases we talked about earlier. So we'll pretend that we have an e-commerce site. And so maybe we're shopping for new furniture for our living room. So we could have a user upload a photo of a living room. And then maybe there's different wall art that we're considering, which these were all AI generated, by the way, but for the sake of this, we'll pretend they're all real. And, we're trying to decide between these 4 pieces of art. Maybe we want a more personalized recommendation. We can't decide. Maybe we just won't buy them, or maybe we could find a really great recommendation from Gemini. So kind of just to start off, and we'll see what it can do, how it defines this room. So we'll just ask it, supply the image, and then ask it to describe the room. And we can see that it gives us this, long, robust description that it's a cozy and minimalistic aesthetic. It describes all the furniture. It describes the color palette. It says it's very natural lighting, that the room feels inviting and comfortable and stylish, and, kind of gives us this large description about what we've uploaded. So from there, we can say, okay, great. Now that you're familiar with our room, let's recommend a new piece of furniture and go ahead and explain why. So Gemini comes back and says, based on the room and the touch of rustic charm, we're going to go ahead and recommend a large textured area rug. And it kind of gives really specific bullet points to the user as to why it might think that. And, well, we're not shopping for an area rug. So we can say, you know what, thanks, no thanks. We're going to go ahead and say, well, actually, I think I want some art to go back on this wall up here. And so from that, we can say, okay, so we have these 4 pieces of art. We supply the URLs in this way, which again are hosted in Google Cloud Storage. We're going to supply all the URLs and load them as image objects within this line here. We're going to prompt the model saying that you're an interior designer, and for each piece of wall art, explain, whether it would be appropriate, and then also rank each one. So personally, I think it's, let's see, if I scroll back down, I would guess that it would rank, let's see, this one might have left. We'll let this initialize and run. But so from there, we're able to see, all the wall art. So we have the living room, we have the first piece of art, and not only are we providing all of these, but we're also specifying them within the order they appear. So by giving them a label, we're saying art 1, that's this one, art 2, that's this one. Gemini is able to reference all of those in its description and kind of more accurately reflect the prompt and what we're asking it to do. So we've displayed the living room, we've displayed all of the art pieces. I think this one would look best personally, but let's see what Gemini says. Let's see, they give descriptions of all of the art. So Gemini disagrees with me. They think this one would be best. Number one was second. So it kind of is able to give all these really tailored recommendations based on the style image that you provide. And it can really help users online shopping, if they're looking for personalized stuff for their home, if they're looking for clothes for their closet, makeup, any of that sort of thing, you're able to get really tailored personal recommendations in real time. Yeah, it's opinionated. It's yeah, you can read that, it's not a fan. It doesn't think that those two would make a whole lot of sense. Yes, question. So we can if we tie together our image generation model within that. So now another use case we can consider is kind of industrial video monitoring to ensure that, in different situations, we're complying with safety. So I found a Google Data Center YouTube video, which is a new feature as part of our Gemini 1.5 Pro models that you can directly supply YouTube links and inference videos that way. So, there's obviously nothing crazy going on in here. But for the sake of this, we'll say, you know what, maybe we're not allowed to ride scooters or bikes in the data center. And we can kind of loop through pretending as if this was a security feed and find moments where this happened. We'd want to be alerted. We'd want to prevent this behavior from happening going forward. Another kind of great case we could see is it preventing stuff like this in real time. So it could monitor scenes and say, you know what, those boxes are stacked kind of high and they're starting to like tip over time. Like maybe we should rescale them. It can provide really specific recommendations based on being able to constantly monitor video feeds and what the data is trained on. So the way that we can do this is we go ahead and prompt it, basically explaining how it's a security expert. You're not allowed to ride bikes or kick scooters in the data center, apparently, in this one. And then we want to be alerted with a specific timestamp if this happens. So we can basically just send this here, prompting with the direct YouTube URL. And I already ran this cell, but it does come back saying that, someone is riding a kick scooter in the data center at 3:59. And they give a pretty specific description. And as you can see from this timestamp in the video, that's too far back. Okay, well, I can't find it, but take my word for it. He is there at 3:59 riding his scooter. There we go. So Gemini was right, which would be a great use case for different things like this in the future. So marketing is another really fun one, using it more as a creative collaborator, but also being able to reason across different images or, videos that you have in this multimodal kind of AI scenario. So again, we're going to supply some images. We're going to parse them in the same way. We're going to say, based on these potential images, maybe write some possible social media captions and a sample ad copy. And we're pretending that we're creating and marketing this new dog bed because dogs are cute and fun, and who wouldn't want to see that? So we're going to create a new memory foam dog bed, and we want to generate an ad campaign around it. So we've gone ahead and, structured the images in the prompt in the same way. This cell did retain, so we've had the images that we're going to display, and then we're going to display the model's output. So you can see we have the first image here, sad dog. Second image, happy dog in dog bed. And third one, really happy dog in house with family. So it comes up with really creative social media captions based on this campaign. It can even so much as see that the dog's name is Remy in these images based on the dog's tag, and it's able to personalize the content around that, which these images are also AI generated with Imagine, our text-to-image generation model. So you can see it gives really personalized instructions. It gives a whole sample ad copy. with voiceovers, transitions. It does a lot of the creative work for you and gives you a really great starting point for your collaboration. So finally, the last kind of visual use case that we can cover with multimodal AI is in the media and entertainment space, specifically with a focus on content moderation. So in this one, we're going to also reason across YouTube URLs, but we're going to showcase batch prediction as well. So how we can reason across a lot at once. So we're gonna, who knows the year in search Google videos? Yeah, 1, 2, there we go. So every year Google comes out with like a 2 to 4 minute video about, just the most popular like search history within that year. So we're gonna look back across all the videos from the last 10 years from 2013 to 2023. All of these videos are about like 2 to 4 minutes in length. So basically now we're going to do some setup. We're going to say, you're a video analyst, carefully look through all the frames of all the provided videos. And in a content moderation standpoint, we could say, we want you to alert us when there's something like that could be perceived as dangerous or harmful. We want to give an alert to users within the videos and on our content platform. So we're also going to parse them through controlled generation, which is our new feature. So we're going to say, large language models can get pretty crafty in how they return their responses, but with this new controlled generation feature, you can highlight and say, I only want the data returned in this way. So we're going to specify a schema where we want an array of objects, and I only want the activity as a string, and I only want the video timestamp as a string, and I'm going to give it an exact format. And I said, please do not deviate from this. So we set this all up within the model, and then we're going to use Gemini 1.5 Pro. We're also going to run these calls asynchronously so that we can process all 10 videos at once and kind of get results back at different times. So we have a function for that. I've already run this because this can take about, it says 97 seconds was the last time this took. So from that, once it's been able to kind of go through all of those videos with the individual prompt, we're then able to extract them and look at a table. So from this table, you could see it went through all of the videos. You can see the year, and you could see what it thought was a potentially dangerous activity that we should alert users to. So Iron Man snapping his fingers is my favorite one from 2019, but and it gives us a specific timestamp in addition in the exact format that we did ask for. So we're able to kind of parse all of these in very, very quickly and extract real business insights, which in addition to moderating content is just a great enterprise use case in general. So that is my spiel for today. And I have one more slide. Another dog, because they're cute and fun. So if everyone wouldn't mind taking this survey, it's a really short survey, 3 questions. Our Google Cloud team would really appreciate it, and our AI-generated corgi also would as well. Thank you so much.
Thank you very much. That was very impressive, and can't wait to try it out. But I'm scared about the cost. You mentioned like some of these things take a long time. We're talking about videos and pictures. How much would it cost, for example, run that notebook ourselves?
So it depends on the model you use. Gemini 1.5 Flash will have a slightly lower cost. Gemini 1.5 Pro, which has some of these features, is different. So depending on your use case, you can go to the Google Docs pages and kind of parse out the costing for all of this. But it is based on tokens. So there's a lot of ways with the API or even without using a Vertex to calculate the token size of your input before you query the models.
Excuse me. When you're submitting a file, does it kind of make a decision on, is it going to do an image evaluation or an LLM evaluation of that file? So for example, I've got maybe an invoice printed out, and maybe it's got a hand-struck line in it, right? So the line's a graphic image, and it has text underneath. Is there a way to get that to understand that line is struck out? I'm trying to read that in as structured data.
So would you input it as an image of the file with the manual struck out?
Yes.
Yes, so it is able to decipher across that. I think I showed in one of the examples that, we had text rendered within an image, but we submitted them all as raw image files. And it was able to say, oh, you know what? I never told it the dog's name was Remy, but it was able to read that off the dog's tag and kind of make decisions about that.
We ran into a problem with that where it wanted to read the text no matter what. And it
Interesting.
kept the line image separate.
The line of the struck out
The
data.
strikeout line, yeah.
Interesting.
So I was just curious because it returned there was some message we found in there too, where it said, I read text. And it wouldn't combine the two together to say that's a strikeout on the text. It was like, it was either you would read the line or read the text, but it wasn't combining the two with that. Maybe we had the wrong model in Vertex AI, but we were doing it in the Vertex model builder.
Okay. Yeah, definitely. I think that's also a question too of kind of finagling your prompt a little bit. And, you know, kind of, you do have to be very specific with the prompts to get your designed output, but the control generation is also super helpful because you're able to specify really specific system instructions to the model and then also control the generated output. So it, you know, can't reason across things on its own. You're saying this is how it is. Please provide me that exact feedback.
All right. Do we have a question? Okay. Okay. The last question, so we move forward.
So how fast is the video processing? For example, when you read the YouTube video, like, do you have a rough estimate of like per frame for like how many seconds per frame or anything that you can share, or we'll have to actually like burn our own money and learn it?
That specific metric, I don't totally know, but I know that running all of them in batch asynchronously took 97 seconds from that last example I just showed. You can also play with the models. Vertex AI is obviously your enterprise developer platform to play with all of these models, but you can also go to AI Studio and sign in with your Gmail account if you're kind of just wanting to play around with the models and try them in general before you really bring them into production.
All right. Thanks so much.
Thank you.
Yeah. Let's move on to our next speaker and also the last speaker for today. Have Satoru. He come from KNIME, and he's going to share some of the lessons learned for using AI to the project.
Yeah, I'll use the hand microphone. Yeah. Oh. I thought I'm sharing, but I'm not sharing. Sharing. Oh, there you go. Okay. Hello everybody. Thank you very much for coming tonight. My name is Satoru Hayasaka. I'm a data scientist at KNIME. It's pronounced KNIME, so K is silent. Our company is located in Constance, Germany. We have an office in Berlin, Germany, and Zurich, Switzerland, and also Austin, Texas. And I'm based in Austin, Texas, and so I'm here today. And I'm part of evangelism team, which we focus on teaching people how to do, so basically try to help people become more like a citizen data scientist. We try to train non-experts into data professionals. And so a lot of teachings, so we do a lot of teaching as a result of that, produce a lot of educational contents. And part of that, so we teach courses geared toward non-experts and beginners. And so a lot of materials that I present might be somewhat very elementary or introductory for you, but please bear with me. So this is this material is typically presented as a 2-hour workshop on hands-on workshop where people actually bring in their computer and they can actually build the workflow as we talk and go over step by step. But for for the purpose of today's talk, so I just condensed it into a 20-minute talk, and so hopefully I'll be able to just get you the gist of what I'm trying to say. So the title of this talk is AI or not AI, and we focus on the use case on fraud detection today. And let's see. And so this is the outline of my talk. So first today, I'm gonna start by giving you a little bit overview of what fraud detection is. And then I'm gonna go over a number of tasks for outlier detection techniques, classical outlier detection techniques. Then I'm gonna explain our attempt in fraud detection using GenAI, and I'll conclude with my final thoughts. And so before I get started, so let me just do this real quick. Before I get into today's talk, so let me introduce a little bit about KNIME Analytics platform. So this is one of the software products that we produce, and so this is a data analysis platform designed for data analysis and data science, and it has a number of nodes that are specialized for different tasks like reading data, transforming data, building and training on data science models, and visualizing insights from the data as well, and so on and so forth. And so the materials that I'm going to present today can be implemented using KNIME Analytics platform without writing a code or programming. And it is a no-code or low-code data analysis tool, so no programming background is required. So that is why we use this for basically to introduce people for data science and other data-related topics. And it is based on visual programming paradigm. So we build a workflow by combining nodes that are specialized for specific tasks. And so each individual nodes can be configured individually to suit your need, part of your data workflow. And as I mentioned, no coding is necessary. And a number of outlier detection techniques that I present today that can be implemented using KNIME Analytics platform, as well as we have a number of API nodes that can interact with OpenAI as well. And so it is open source, and you can download it for free from our website. And it is open source, so we do have GitHub repository. Since we are at GitHub, we do have a GitHub repository where we post all the codes on GitHub, and so it's a huge, massive amount of code, and some people do go over our code and customize a KNIME Analytics platform their purpose, but most people typically download from our website. Okay, so now let me start talking about today's focus. So it's going to be a fraud detection. So fraud is defined as intentional deception designed for unlawful gain, often financial gain, or to cause harm to others. And typical types of financial frauds include tax fraud, credit card fraud, securities fraud, insurance frauds, bankruptcy frauds, and so on and so forth. Frauds occur very rarely. For example, among millions of transactions among millions of credit card transactions, only a few hundreds of them are fraudulent. And since the occurrence of fraud is very rare, so the occurrence is very rare, so we can't really train a classifier to identify fraudulent transactions. So we have to come up with a different way of detecting frauds. And even though the occurrences of frauds are very rare, each case of fraud can carry a significant financial damage. So that's why we are eager to detect those frauds. And so fraud detection techniques are applications of outlier detection techniques. So the goal is to identify data points that are significantly different from the majority of other data points. And so the question is, how do we define significantly different? So that is a good question. And there are different ways we can define this statistically. On different way we can define significantly different based on visual inspection, statistical reasoning, clustering, machine learning, and so on and so forth. And so I'm going to go over some of the classical outlier detection techniques. So the first technique is visual inspection. So the goal here is to identify which data points are out of place. And so this is done on the basis of someone looking at the plot. And so that means manual intervention is needed. Manual intervention is needed to identify outliers. So this approach is somewhat subjective, who the observer is. So in this particular example, these two data points have been flagged as potential outliers. So this one, for example, is flagged as outlier because I guess it lies on the extreme end of the data point. So it's extremely high on both features. And so some people may feel okay about this. Some people may feel uncomfortable about this data set being included as part of this data set. And so some people may not flag this one as outlier, but some people do. And so this one is flagged as an outlier because it doesn't really follow this linear trend that is exhibited by other data points in this plot. And so this one might be more unanimously, people may agree that this might be an outlier. And so this type of visual inspection on outlier detection can be done on 1 or 2 dimensions of data at a time. So you have to visualize data. And in most cases, 1 or 2 dimensional data visualization is all you can take. And so you can't really automate this since it requires human intervention. And outlier detection based on a statistical reasoning. So the goal is to identify whether or not outliers can occur by chance alone. And so in this particular case, let's say, for example, we have this pictures of box plots. And all these different parts of the box plots actually have a different meaning, different quartiles, and all the length of the whisker is tied to the box of the width of the box, and so on and so forth. And we can come up with some kind of more consistent criteria based on the distribution of the data. And since it has a consistent algorithm, this can be automated to be applied to a larger data set. But one downside is that you can only focus one dimension at a time, since you are only dealing with a unidimensional distribution. And so in the next technique, in outlier detection technique based on clustering, the goal is to identify, so basically one of these things is not like the others. And so what happens here to most outliers is that the outliers tend to be isolated from other clusters. And so you'll be able to identify outliers that doesn't seem to belong to any of the clusters. And this technique works on higher dimension data, higher dimension meaning 2D or higher. And this technique can also be automated. You can implement this automatically as well. And the one downside of this approach is that the clustering algorithm itself requires some hyperparameter tuning, or you need to define hyperparameters. Let's say, for example, if you want to do k-means clustering, then you need to define the number of clusters in your data set. And so this approach, so this is a machine learning based approach of isolation forest. And the question we ask here is, how easy is it to separate a particular data point, a potential outlier from the other data points? And so in order to isolate this outlier, what you do is you basically cut the data set, apply a cut to the data set, and And so if the data point tends to be an outlier, so that means you need fewer cuts, or you just need fewer cuts, few number of cuts to isolate that data point. But if the data happens to be in the middle of, I guess, other data points, then it is hard to define those series of cuts to isolate that point. And so this is how we can identify outliers. And so this series of cuts can be summarized as a decision tree, and it can be automated. So this process can be automated, and but the downside here in this approach is that if you are able to find an algorithm to identify outliers, so it is basically a decision tree. So it's basically a series of decision rules, and so there really isn't an easy interpretation of that. Okay, so now I'm going to showcase one case of fraud detection. So in this case, what we have here is that in our data set, we have a number of PDF documents of some investment contracts. And so in this case, so I highlighted 3 different fields in this contract. So this is a contract number, contract amount, and as well as the date of execution. And if someone, if these contracts are to be fraudulent, and these are basically the likely fields that are to be tampered or manipulated. So we focus on identifying any abnormal occurrences in these fields. So I'm going to apply all those 4 outlier detection techniques that I mentioned. So first, in the first approach of visual inspection, so I plotted the payment amount versus date, and I'll be able to identify these 2 data points that are far different from other data points. And on the basis of statistical inference, so I plotted a box plot. So this is actually a box plot. It kind of looks like a bit bar chart, but because the outlying data points are so extremely I guess, large in terms of magnitude, so the box itself is squished close to the x-axis in this case. Oops, sorry. By clustering, I was able to identify these 2 data points that are forming a cluster of its own, and all the other data points are forming a cluster of another cluster. So, so in this case, I was able to identify these outliers. And I also applied the isolation forest to this same data set, and I was able to identify basically the same 2 data points that have been identified by 3 other methods. And so far, I was able to showcase that all these classical non-AI fraud detection technique, outlier detection techniques is working here. And I'm trying to see if GenAI model can basically do this kind of fraud detection task. And so we use OpenAI's GPT 3.5 Turbo, and we pre-process the data using KNIME Analytics platform, reading all the PDF documents and extracting all these documents, etc. And we did a little bit of prompt engineering to ask LLM to identify fraudulent transactions. And we also provided a complete data set as part of the prompt as well. And we used the OpenAI API via KNIME Analytics platform. So this is what's happening here. So in the first 2 segments of this workflow, so what we are doing is, so I'm going to just give you the gist of what we are doing. So we're reading a number of data point, number of documents, and extracting information. And here we are generating a prompt to be passed on to LLM. And so this is the actual prompt that is passed on to LLM. So the instruction is simple: identify the outliers from the following CSV dataset, etc. And we are providing all the rows from the data, including the header. And so what happens here is that, so this is the response from LLM. So, so it was able to identify these 2 outliers that have been previously identified by the other outlier detection methods. So it seems to work in this case. However, and what happened here is that, so we changed the prompt a little bit. So in the initial prompt, we said, identify outliers in the following CSV data set. In the second prompt, we said, identify the outliers in the following data set. So we omitted the term CSV. And what we got here was that we were able to identify 3 outliers. 2 of them are fraudulent contracts, and 1 of them was a legitimate contract. So, so in this case, it kind of shows that the outcome wasn't really consistent in this case, and only the prompt changed slightly, but it really produced some kind of unexpected results, and we don't know what happened in this case really. So, and so does this mean GenAI, this type of approach cannot be used for fraud detection task? But there is a use for GenAI on the grand scheme of fraud detection task. And so what happens in a fraud detection task is that first you need to access the data and find the frauds in the data. Then what happens next is you have to generate a prompt. You have to generate an email alerts to the user. But in order to do this, we incorporate our knowledge base to generate a personalized email. So we've already seen from the first talk that it's important to generate a personalized response to users, and we'll be able to do this by using GenAI. And so in this case, what's happening here is that so we are able to identify all these fraudulent outliers, and based on the information from the outliers, such as name of the account client and account number, the amount, etc., we can just use that information and pass on that information to GenAI to just generate this type of generic looking alert email. And the problem with this type of alert email is that, so it sounds very impersonal. It doesn't really have like, it feels somewhat formulaic and lacks personal touch. And so we try to make it more personal. And so in this case, we are going to do that using RAG. And so in this case, what's happening here is that we have a number of documents with information about different investment products. And we create a document vector, vector store based on that document. And we use that information in RAG. And so this is down-to-earth explanation of RAG. So as I mentioned earlier, so we tend to teach this course to absolute beginners. So this is the way we explain RAG to absolute beginners. So we have a collection of documents in our knowledge base at our company, and these documents have been transformed to vector store to be represented in a higher dimensional space. And then the user prompt or user query is also transformed into the same vector space. And so what happens next is that we retrieve the documents that are most similar to the user query. And these retrieved most similar documents are then used to generate more engineered prompt. So in the prompt engineering, what happens here is that, so this is the original query to the vector store. So in this case, we are just asking the type of the product. So statutory stock option agreement, and this has been passed on to the vector store. We were able to retrieve 2 similar documents. And based on these 2 similar documents, we basically created an engineering prompt, engineered prompt. So this is basically a complete instruction to OpenAI on GenAI to draft an email letter, alert email. And in it, we were able to say, so this person has an account on statutory stock option agreement, and this is the information that you should use in personalizing the alert email. And so we pass on this prompted engineered prompt to LLM. And what happened here is that, so I'm going to just highlight this paragraph that wasn't really in the original email, but we were able to add additional information, a little bit more personal touch to this email alert. And another thing that I want to note here is that we are, GenAI is also great for generating multilingual text. And so a lot of companies in Europe probably have to go through this type of scenarios. You have to alert, send the emails to customers in different languages. And so the first one is written in Russian and the second one is written in English. And so if you go back to the prompt, I apologize, the typeset is really small here. But in the engineered prompt, so there's in the first line of the instruction is to generate the email in English, but you can just change this to Russian. It actually does produce Russian alert email without really providing any kind of Russian information in Russian. And so on that note, so AI or not AI. So in order to answer this, I'm gonna let you think a little bit about Occam's razor principle, which says all else being equal, simpler explanations should be preferred over more complex ones. And so the answer is yes and no. Sorry for being non-committal. AI is used for some tasks, such as email generation tasks, but not worth the effort for some other tasks in outlier detection tasks. And so at this point, I'm sort of like really harsh on AI. But AIs are good for some other types of, I shouldn't say outlier detection, but anomaly detection tasks. A lot of our clients use AIs in production lines, taking thousands of pictures of products produced in their production line, and are able to identify defective products out of the production line using AI. And implementing that kind of tasks in a classical non-AI based outlier detection technique might not be worth the effort because we have to extract all these different features or landmarks, etc., from the image and analyzing in a summarized data points. And so that may not be an easy approach. On the other hand, if you use AI, then you'll be able to feed that data into AI, and you'll be able to identify outliers or anomaly fairly easily. Okay. So on that note, so thank you very much for attending today's seminar. And so let me introduce one book that we have. It's called Production Practicing Data Science. It's a collection of use cases introducing different data science topics. And one of the topics covered in this book is fraud detection. And so this book is freely available from KNIME Press, and you can download it. And I brought a number of postcards out there on the table. Please take those. So there is a link for downloading our software tool, as well as a number of resources you can use for our software, and also a number of our social media channels where you can learn about more about what our company does and some of the use cases, as well as how to download and start using KNIME Analytics platform as well. We also brought some highlighters and mints. I don't know, mints might be already gone by now, but highlighters, those are new highlighters where the tip is transparent. So when you highlight, you can actually see the the piece of document that you're highlighting. So that's really great. So if you take nothing else from this talk, please take some of the highlighters with you. And on that note, thank you very much for coming, and I hope this talk was educational and informative. Thank you.
And if you don't have any questions, if you're too shy to, oh, sorry.
So you mentioned that it's not worth it doing the outlier detection with this, like because of the feature extraction or what was the reason you felt it's not worth it doing this analysis as opposed to other machine learning stuff?
Yeah, so in this particular case, so we know that we are focusing on these three features, and other techniques can do it fairly efficiently without going into AI. So that's the reason why. So but some of the other tasks I mentioned that if you're taking a look at the pictures of thousands of pictures of coming out of the production line, etc. And you're trying to identify anomalies among those thousands of pictures, AI is probably more efficient, because in a traditional approach, it's not just focusing on a few columns in a data table you can summarize, but you're looking at images that cannot be simply summarized by those features.
But you mean AI or GenAI? Which one? Because for fraud detection,
yeah, so it's not necessarily GenAI. So it's more like CNN type of approach, more like a traditional neural. I shouldn't say traditional, like a more neural network based approach. Yeah.